Welcome, everyone. This is a very introductory workshop, although if folks have more comfort with Git than I know about, I can sort of throw away the plan and we can talk about some more advanced stuff. I know my team members, so Marielle, Nikki, and Robin, what's your comfort level with Git? You can, there's a chat option if you don't want to be on mic. Chat. Okay, so we're gonna share my screen here. We're gonna find the chat. Here, chat. Nikki Wolf, what about you? If you're able to type, I know you said you might not be. Okay. So anyway, this is Git for everyone, and I really mean that pretty seriously. We're absolutely gonna start from the very basics. We're going to avoid the command line mostly, and in general, just talk about how you can do what you need to do in Git without a lot of fuss. So, what is a Git? Nope, that's the wrong definition. Git is a distributed version control system, and that's a lot of jargon. We call, there's a whole class of things that we call version control systems, and Git is a distributed. But let's go through what that actually means. Distributed means that everyone working on a project has a complete copy of all of their work at all times. Older version control systems had a thing where basically there was only one complete copy and it was in a central location. Everybody else basically just had pieces, which cut down on space, but it also meant that if something blew up with the main server, you were in big trouble because reconstructing it was an issue. It completely removes that problem because everyone always has a copy. Version control is about the purpose of Git. What Git is for is to let you keep track of changes to your code, your documents, whatever. How many people have written like a big paper or something and they've saved, you know, paper, important paper underscore final, important paper underscore draft, important paper underscore final, important paper underscore really, really, really final this time. Git means you don't have to do that ever again. You just save your file and it always knows what version is current and it always lets you see earlier copies. System just means that Git handles the details for you. Also, I just noticed that my slideshow is broken again, which is fun. We'll fix it later. There's supposed to be a background image here. It's not here. So wonderful technical difficulties. Git handles all the details of that for you. You don't have to name things underscore final. You just tell Git, hey, I've made a change I want to keep track of, and it magically does the rest for you in a way that's pretty invisible to you. So now we're in the getting set up portion of things, and some of you may be able to skip this. If you've already got Git installed, you definitely don't need to worry about these directions. We're going to use source tree because it's free as the GUI that we demo in this. There's plenty of other Git GUIs. I think some of Cantilever folks already have Tower, which works great. They're all pretty similar. So if you don't have Git downloaded, download Git now, please. If you don't have the GUI downloaded, it's pretty small, so download it. In case you can't get those done while we're in here, just, yeah, we'll be demoing stuff. But assuming that you have these things, we need to configure a couple of things with the command line tool. This is pretty much the only part where we need to use the command line tool. So Nikki Munson, this part's definitely for you.
Great.
Find terminal on your Mac. It should be pretty easy to find. Do not type this initial less than sign. I don't know where that came from. I will fix these slides. Obviously typed your actual full name and email address, not the fake ones. Tell me in chat when you've done that, Nikki. So that I can skip to the next slide. You there, Nikki? Uh-oh. So while that's happening, Git is mostly, its DNA is all very command line, which is why we have GUIs, because a lot of folks aren't super comfortable with the command line. I mean, Git was originally invented by Linus Torvalds, who's the same guy who wrote Linux, the Linux kernel. So he's not real big on graphical interfaces. He definitely likes things that are old school. As a result, Git has a lot of complexity. We're not going to address a ton of that today, but we'll get peeks at it. The nice thing is that the modern crop of user interfaces for it makes most of our common tasks just super simple. The complexity, I mean, I was showing these slides to a friend of mine last night, and she pointed out that she still looks up something in the Git documentation once a week. So I don't want to make it sound like we can teach you everything about Git in a day, because or an hour. We can't. It's a lot. But we can definitely get folks comfortable enough to work with it right away and have 90% of everything worked just great out of the box. Oops, sorry, I didn't mean to do that. Nikki, there's the slide. You can pull that up in your browser. Andrew or Ty can probably help you in a side channel to get terminal open and set up. So next thing, GitLab. GitLab is a hosting provider for Git repositories. If you remember a few slides ago, I said that Git is distributed, so it's not all hosted on one central server. We all have a copy. That said, most of us who are working on collaborating with other people do use a hosted provider to keep a sort of canonical copy. You've heard of GitHub. GitLab is along similar lines, and it's generally the one that Cantilever recommends and uses. If you don't have an account at GitLab, you can sign one up for free, and you're welcome to go do that. Why we like GitLab, it's got a good interface. It's got good issue tracking. I like their issue tracking better than GitHub's. In fact, issue tracking is like when we're doing QA and we have bugs in our code, we can keep track of all of that and resolve them and say, I've resolved this issue, can you please retest? All of that stuff can happen in a GitLab interface. It also lets us deploy projects to production really easily. And a feature that I think even some of my team members might not know that it has is it comes with large file support baked in. Git by default doesn't do so great with really large files, and by really large files I mean like giant Photoshop files. 500 megs of one image or whatever isn't really what Git was designed for. And you can clog up a repository really quickly with that if you're not careful. GitLab, however, has baked in support for a plugin that lets us do that. Sometimes it can be really helpful to store assets like that in a repository because then they're all very central. Okay, the SSH keys, we are actually, since Nikki is still having trouble with her terminal, does everyone else already have Git set up completely? Mariel, and the other Nikki, I think, are the ones that I don't know. Okay, great. So we'll skip this stuff for now. We can always revisit it when Nikki sorts everything out. So now we're going to talk about working with Git, having gotten the setup stuff out of the way. Again, we're a little on the fly here because I didn't know folks' comfort level in some cases. Okay, first we need some basic vocabulary. A repository, which you'll often hear called a repo, is just a project. It just means a folder, basically, where all of your related work is kept. It will, in fact, be a folder on your hard drive with as many subfolders as you want, but one top-level folder will contain the whole repository. Everyone is going to have a copy. And then there's also a remote, which, as we discussed, Cantilever usually does on GitLab. There are other providers. Some big companies self-host, so you've got basically the equivalent of GitLab, but it's at a private URL that only company members can get to. All works the same way. We talk about that remote repository being upstream of everybody's local repository. This is just a sort of a point of terminology that you'll want to be aware of. When somebody talks about pushing something upstream, they mean up to that centralized canonical repository. When we talk about pulling down a local copy of a repository, we say that we're cloning it because we get an exact copy. This is all very basic stuff. Again, okay, so hang on, I don't have source tree open, and apparently I can't type this morning. Okay, let's clone this repository. We do that by going to clone, and you'll type in this URL over here. And give it a folder. You don't need to care about this local folder or the advanced options. Just paste it in. And then say clone. If you're not using source tree, if you're using Tower or whatever, should all be pretty much the same. Oh yeah, good point. The URL should be in the chat because then you don't have to type it. Excellent plan. I already have it cloned, so I'm not actually going to clone it. Okay. Once we have a repository, what do we do with it? Well, we do anything we want with it, but generally the point is that we're going to manipulate files, right? We're going to add stuff, we're going to change stuff, and then we're going to stage those files and commit them. But we need to know what those things mean if we don't already. So let's talk a bit about them. A commit is any change that you want Git to keep track of. It can be a change to a single file. It can be a change to multiple files. Think about, for instance, if you have several files in a project and you suddenly realize that your name is spelled wrong in all of them. You changed your name in all 5 files belonging to your project. That's a single conceptual change. So generally speaking, we would want it to be a single commit. Think about it in terms of checking a single item off a to-do list, probably. You may have multiple actions involved in that item on your list, but it's still just one item on your to-do list. Under the hood, Git doesn't just store those changes exactly. Git stores a snapshot of the entire state of your project at every point where you make a commit. So at any time that you can restore to any committed change, you can figure out what happened, you can revert individual changes and not others. It's very versatile in the way that it handles these things. Staging is poorly understood because a lot of times we actually stage and commit in one step, but basically Git has sort of an imaginary box where it keeps things that haven't actually been committed yet, but it knows they need to be committed. So first we tell Git to stage a change and then to commit it. Everybody with me so far? Okay, branches. In a new repository, you'll generally be on the master branch. You never want to be on the master branch ever, unless you are the owner or unless you are an owner of the repository, unless you're in charge. Because the way that most of us work with Git, master should always be in a state where you can upload it to a production server and it just works. So you never want to be on master. Ever, ever, ever. So in order to not be on master, you'll see actually that when you in source tree, you should be on the master branch of the repo probably. Your interface probably looks like this right here. But you see this branches item right here. You may or may not have develop in your list. You probably do not. So let's walk through creating a branch now. But what's a branch? A branch is a workspace. It's like a file box. If you want to work on a particular set of things, you have a file box that contains the things that you want to work on, and you pull it over to your desk and set all the other file boxes aside. That's a branch. You can make as many commits as you like inside a branch, and nothing else from outside that branch will affect your workspace until you tell it to. So a lot of times we use branches for things like, well, I need to add a new feature, or I need to work with some images, but I'm not sure what all is actually going to make it into my final project. So it's a way to isolate things until you're ready for them to be, well, until they're ready for prime time. We talk a lot about pushing and pulling in Git. Pushing is when you send stuff from your local copy of the repository upstream, and pulling is when you pull in other people's changes down from the remote repository. In order to do either of those things, we need to set a local branch up to track a remote branch. We need to say, my copy of develop needs to track the remote copy of develop. So again, this is all really easy in source tree. So let's do this now. If you've got source tree open, just click this branch button. And we're going to say that we have a branch and we'll call it my first branch. Source tree creates that for us, and it also checks it out for us, which is to say that it is now our current workspace. We have grabbed that file box, we've put it on our desk, we've moved all the other files off our desk. It's checked out. When we want to put our work back into the mainstream, when it is ready for prime time, we go through a process called merging, which happens mostly automatically, and integrates our changes into master or into another branch. You can merge any two branches, but normally the way that our workflows work, we're merging from our specialized branches into either master or develop. Also, source tree has suddenly decided that it doesn't like me. Hang on just a second. So does everyone have a branch created? Okay. So let's do some actual operations here. We're going to edit a file that's in our branch. Here's our README file. Here, I've created a folder actually called project in the repository. So you can just open this up in the Finder, or in whatever equivalent. Just open the folder that you created in the Finder, and you can find your repository. For me, it's over here. Here's my repo. So I can just navigate to this. It's just a normal folder on my hard drive. And then in the text editor, we can edit this file. So see, I made a test file. Let's see what happens. I've just typed, I've made a change, come back to source tree, and source tree shows me that I have an unstaged change. And it gives me options. It says stage just the selected file or stage all files. A lot of us stage all files. It's bad practice, generally speaking, to do that without thinking carefully about it. So try not to. You probably will get into the habit of it, but try not to get into the habit of it. We're going to stage the selected file. Staging, again, just sort of moves it notionally into a transitional area. It puts it in a box for Git that says, this is part of my next commit. And then we can actually commit the change. Committing means that we have a message. We always have to put in a commit message. And in general, it should be descriptive. So we're going to say testing, making changes to a file. And we just say commit. And then Git or source tree tells us that we have nothing to commit. Hey, look, we don't. Now Let's try adding a file. Test add file. Source tree says, I have a file that you may need, you may not need it. It's not tracked. And we do want it, of course. So we tell it to stage. And then, again, a lot of non-GUI program, like if you are using Git from the command line, you will frequently stage and commit in a single step. One of the reasons that I wanted to showcase using a GUI is because those really are two separate steps, and it helps to understand Git better if you understand that they are two separate steps. So we've staged a file and we are committing the file. So we've done those, and we now have some changes in a branch, right? So now what happens? We check out master, and oh look, our changes are gone because we're in a different branch. So our next step is to merge things. Again, source tree makes this easy. Except that I just did it from the wrong thing. You are always merging from another branch into the branch you currently have checked out. That's actually an important thing to remember. And I fumble clicked it. So I want to be on master, which is the branch that does not have the changes, and I merge in from a different branch. Source tree tells us to pick a commit. We can pick this commit and merge it in. And then we have our changes again. Super easy, right? This all really seems too good to be true. and it is. There are a lot of things that can technically go wrong. Although the only one that you're likely to run into on any kind of regular basis is a merge conflict. Merge conflicts can be scary and awful. The best way to minimize them is to make good commits with good messages and to be rigorous about branching rather than working in a main branch. Like, don't work in master. Always make branches for your changes. But you're going to have them happen. They are going to happen. So let's deliberately make a simple merge conflict and see how to resolve that in source tree. So I've checked back out our first branch. We're going to change this text file. We're going to commit that change. Then we're going to check out master, which again, never work on master. This is just a practice repo. And we're going to make a different change. Okay. Now what happens when we merge in oh, look, we have merge conflicts. That's always going to show up in file status. And it gives us this weird hopefully you can see it. You get some gibberish characters in here. Well, they're not gibberish, but you get something that says we have some changes that I don't know how to resolve. And you can do several things. You can either delete lines directly in here, which can work for small files, or you can come to resolve conflicts, which is usually easier. So you just right click on the file or command click, and you've got several options. A lot of times you know which one you want. So you can just say resolve using mine, that's the current branch, or resolve using theirs, which is the one from the other branch. Other times, if it's a big file, you may actually need to go through it, in which case you want to launch an external merge tool. I don't apparently have my external merge tool configured. So there are several tools that we can use for this. I'm sorry, this was configured. It apparently decided that it didn't like it. It's okay, Rebecca. Feel better. Okay. Okay, I can't stop and do this. I don't know why it's not working. Anyway, you can resolve conflicts using an external merge tool. I will show you basically what that looks like. We just can't do it from inside the it'll look like this. You'll get something that looks like this, and you'll be able to see, oh, say, here's what my different changes are. And you'll be able to say, okay, well, this one needs to go over there. And now look, my lines are the same. In our case, we will have to do this manually. You've gotten an unexpectedly good look at what resolving merge conflicts looks like, which is it's always more of a mess than you think it's going to be. Now we're going to stage that change it's automatically created a commit message for us that says, I had a conflict and I resolved it. We can leave it like that. And then there it gets committed. You'll notice it also created these backup files, which we don't want. We can just delete them. Another operation that I forgot to mention here is that if we move a file, Git is usually smart enough to determine that it's been moved. So let's just show you what that looks like. Git has registered that we both removed and added a file, which we did. So we stage both of those changes and we say moved a file. Git is smart enough under the hood to actually figure out, you can see there's only one file in here now, even though we staged two. It's smart enough to figure out that we moved it. So that's our basic set of operations with Git. History, though. History is really important. That's the whole point, remember? I mean, not the whole point, but it's one of the big advantages of Git is that what if we need to get back our old copies of things? Well, we have a history. If we click on a branch, we'll always see it. Git histories in a GUI. See, this shows us that we have different branches and it'll tell us the colors of it'll color code them for us. So this change was made over here on my first branch and then merged back into develop. You see how the little lines go? We branched off, we made a change, we merged. Down here, we have a set of commits that are only in develop, which is why there's no merge back, you see. Git's really smart about knowing which changes are where. That's kind of its whole point. This log will let us see what changes we made at any point in time. Like, oh, look, this is a change from before we were on this morning. My slides are actually in this same repository. So source tree is showing me the history of this file. It says I removed this line and added this line. It'll do the same thing. It'll say you removed this line, you added a line, you changed a line. You can also right click on a file when you're in this view and say log selected, and it will show you the whole history of this file. We've also got a command called git blame, which is what it's called when it's the command line. Source tree calls it annotate, but it's the same thing. So if we right click and we say annotate selected, this view takes some getting used to, but it's super helpful. This goes through every line in the file and it tells us who changed it last and what commit it was changed in. See that? So then we can always look. Every commit in Git is identified by one of these gibberish numbers. It's called a hash. this tells us what the hash of the commit that was changed was. And we can then right click on that commit and say view in the full log. Oh, look, here's our commit. This tells us everything that was changed there. And again, it does this for every line in the file. It says this line was changed in this commit. This line was changed in this other commit. It is extremely helpful and versatile. And you should learn how to use it. There's also a command called Git Bisect, which is out of our current scope, but I definitely encourage you to read up on it, which lets you go through a repository and say, okay, it's broken now. It wasn't broken a week ago. So somewhere in the last week, someone broke it, but I don't know where. Git Bisect is how you get the answer to that question. It will nail down the specific commit where something broke for you. Okay, so this has been kind of a whirlwind tour. What have we learned? You've got Git set up on your machine. You have learned about how to set up a repository, access a repository, do all of the basic operations. You know how to resolve a merge conflict. And you have gotten an overview of how to find the history of files and figure out how to reverse changes. If we need to, that I actually didn't mention. So if we need to reverse a commit, for instance, if we need to undo a change that we made, we can right click and we can say reverse commit. And what that does is it doesn't actually delete it. Nothing ever gets deleted in Git. No history ever gets deleted unless you do it deliberately, which you should never do. What this does is it makes a new commit that reverses all the changes from the old commit. We have another merge conflict now, but we don't care. The point was to show you that menu item. Reverse commit makes a new commit that reverses all of our changes. So if we accidentally changed a file and we need to change it back, that's our easiest way to do that. And I expect there are questions since this was all at a breakneck pace. So why don't we take questions now? I'll stop sharing for the moment. Okay, go ahead, Robin, please. Marielle, it wasn't too basic for you? Okay, space is not a problem in Git, Robin, generally speaking, because it stores snapshots, but it doesn't actually store new copies of all of the files. If you have a file that hasn't changed, Git basically just stores a reference saying we've got a file, it hasn't changed. So even though it is always taking these complete snapshots, those complete snapshots do not involve copying whole files. They're more like making symbolic links. There's actually an invisible folder called .git that will happen. This is actually where Git is doing its magic. It's hidden normally, and it stores a list of objects, which are basically lists of files, and it's the way that the whole snapshot process works. And they basically work as a sort of a symbolic link. They're not actually implemented as symbolic links because those don't work right across systems, but yeah, Git does not have to store copies after copies after copies of everything. Good question though, because yeah, it could easily be an issue. one of the reasons why large files aren't large binary files like Photoshop files aren't good to keep in Git is because it does have to store new copies of all of those. That large file support plugin that GitLab has kind of works around that problem in a way where it doesn't take up your whole hard drive. So you said you had 2 questions, Robin. That's also a good question. Git will store anything. Git doesn't care ultimately. The question is mostly just whether you can sensibly figure out the differences between files for purposes of like resolving merge conflicts. And that does get tricky with things that are not text. There are some workarounds and things for stuff like Word documents. Word documents, if you're working on like a big presentation for school or whatever, that's a great thing to keep in Git. Even if you don't have one of the plugins that will let you diff the files as text, it still means that you've got copies of everything and you can always go back and look at changes that you've made. It's just a little more manual process. Anything where you feel like there's going to be a lot of revisions to a given file can get at least some use out of version control. Again, whether or not you can keep it as, whether or not you can use some of the automated tooling is an open question, but it's still, I mean, I'm a big advocate of just telling everybody keep your files in Git, keep any documentation that you're writing in Git, even if you're writing it in Word, because worst case you can at least restore an earlier version after you deleted something. You're right that mostly it gets used for code and development because that's where there's a lot of text files, and text is really what Git is designed for at heart. There's an interesting application that I'm aware of also that leverages Git for Photoshop files in some really interesting way. It uses Git under the hood but has its own whole interface. I don't remember what it's called. I would have to look it up. But that's another potential use case. Again, files that have a lot of changes and people frequently go, oh God, I made this change and now I need to undo it. And I can't because I saved the file in the meantime. If you ever find yourself saying that, I would say it's a good use case for version control. Excellent questions. Thank you. Anyone else have any questions? Yes, I do, Andrew. There is a really good book by the A Book Apart people called Git for Humans that I recommend wholeheartedly. It's definitely much more focused on the command line. Oh, you said slightly more advanced topics though. There's a really good talk by one of the people who did some good early work on Git that I think is really important. I can look up the URL of that and put it in, I will put it in the README of this project repository. I will create a further resources section of this repository and you can find it there in a day or so. How's that? Because yeah, there are a couple things I can think of, a really good video, a couple of walkthroughs. There's a lot of really complicated conceptual things going on in Git, and I've definitely breezed over most of that here. So thank you so much for going through this with me. I hope that it was helpful to people.